Hello everyone. Uh, Today we'll be going to talk about linked list. Now, before we are going to talk about linked list, let me tell you why linked list is required, or else what is the importance of linked list. Now, let's see to understand why it is required or what is the importance of linked list. Now, so this is memory. So it is just like of a picture of memory, half the way we'll store the data elements inside of a processor. So for the better clarity I am drawing this. Now look at this. It is what a memory is just like a long tape of bytes. Okay. Now, so I have written this instruction which is int x. So what memory manager will do, the moment when it compiles this line int x, memory manager will allocate 4 bytes of memory. So I told you already in the previous videos, that is 4 bytes will be allocated if it is typical processor, and 2 bytes can be also allocated if it is a traditional computer. Now I'm taking the example of 4 bytes. Even in the previous videos also I took the example of 4 bytes. Now look at this. So I gave this int x. Now what memory manager will do is, memory manager will find 4 bytes of memory to allocate to this variable. So this, in this long tape of bytes, it will be allocating this 4 bytes of memory. Assume this. Okay. This is what the memory which is allocated for this variable. So after this, compiler is saw one more line of code in the same program, which is int a of 3. Now what memory manager will do? If it takes 4 bytes for single variable and there are 3 variables, as array definition is collection of data elements with common name tag. Now that is what common is, what integer. So all these 3 are belongs to integer. So if one is require 4 bytes, 3 will require 12 bytes. Now memory manager will allocate contiguous memory of 12 bytes. This is continuous or contiguous memory. Why? Because it is an array. So A of 3 means what? 12 bytes memory manager has to allocate. And this 12 bytes should be continuous memory locations. Now assume that, so these are what the memory which is allocated for this A of 3. Okay. Now look at, now if user wants to increase array size, it is A of 3. Now I user or we wanted to make this A of 3 to A of 4 or A of 5. If it is A of 4, how much memory is required? 16 bytes, right? And that is 16 bytes in a continuous way, in a contiguous way. Memory required 16 bytes, as no slot is there on the above. Look at this. So up to here A of 2 element was available. Now from 11 up to 109 it was occupied. So you left with what? 110 is free, 1111 is free. And from 112 it is already given to x variable. So in this contiguous memory locations, only 2 bytes of memory is available to use. But how much memory we need? 4 bytes. Memory manager cannot allocate the memory here, as it is no slot to allocate for the next index. Fine. Now what memory manager will do is, a fresh block of 16 bytes will newly allocated. So this is what the drawback of arrays. And the second drawback of array is, if I wanted to give A of 50, memory is allocated 50 into 4, which is 200 bytes. But I want to store elements of 10. The memory is 50. In each declaration part, I gave A of 50. 50 means what? So on the long tape of memory, all 50 bytes will get allocated for this instruction. Okay. So from 100 to 200 bytes, all these will take 200 bytes. So this much of huge memory will be allocated to store this values. Now So as I have given fixed size array, every time I don't want to give 50. So what we'll do, we'll take some scanf statement to read n value. Now this n value may vary from time to time. So once I wanted to give 10 bytes, what does it mean? Remaining memory will get wasted because I'm going to utilize only 10 bytes of memory. That means only 10 numbers. That is 10 into 4, 40. Out of 200 bytes, I'm going to utilize only 40 bytes of memory. So remaining 160 bytes of memory will be wasted. So this is the problem with fixed size of elements. And this is the second problem of arrays. To overcome these two issues, what we'll do is, we'll provide a solution which is linked list. Did you understand? So the first drawback is what? It is contiguous memory locations. The second is what? Fixed size. So now the solution is linked list. Linked list is linear data structure. What is linked list? It is a linear data structure, and it is also a collection of data elements where data items will not store in contiguous memory locations. So this is what definition of linked list. Linked list is, it's a linear data structure and it is collection of data elements where data items will not store in a contiguous memory locations. How it will store then? It is not having fixed size, because we found two drawbacks and the two drawbacks has to be overcome. The first drawback is what? It is a contiguous memory, and the definition itself, it says that it is not contiguous. So first problem is done, right? Solution was done. Second is what? It is fixed size. Now linked list is not fixed size, it is a dynamic memory location. Did you understand? Linked list is a dynamic memory allocation. That is, whenever I wanted to store the data, according to that only we will be allocating memory. Now look at this, how linked list will work. Now this is what I am going to talk. So assume that I wanted to put 3 elements into linked list. So this is my first element, which is 10. So what we'll do is, we'll put some memory. What is that memory? 4 bytes. Because I wanted to put integer. So this value is integer. It takes 4 bytes of memory. Okay. Now I wanted to put one more. It is what? Collection of data elements, I said. So how many have I? Have 3 elements. And I told you that it is not contiguous memory or continuous memory locations. Then how I can work with this? If it is not continuous, how I can work with this? So I can fetch, or I can go to this once I know the address of the second element. So what I'll do is, I'll establish a link from my first element to second element, and this link is reference, or this link is address, such that I can go from first element to the second element, because I am giving a link, and this link is what? Address. When I wanted to go to the second element, so before I go to the second element, I will be knowing the address of this. With the help of address, I am going to see the second element. Fine. So this is how linked list will work. Now let's see. So this is what, again, the type of memory, or it's a memory, it's a snapshot, or it's a photo of memory. Now this first 4 bytes of memory is given to store the data, and next 4 bytes are given to store address. Why 4 bytes? Because we were already discussed many times, right? What is int a and int star p. So what is this integer? Star p is a pointer variable which stores address of other variable whose value is an integer. Am I right? Star p is a pointer variable. It is going to store address of other variable, and this variable, whose variable value it is storing, that the data type of this variable is integer. So it takes 4 bytes of memory as it is an integer. So it takes 4 bytes of memory. Now look at this. 10 is my first data element. Now I left some 4 bytes of date, 4 byte space to store address of the next node. That is what linked list. Linked list will store address of the next node. Now, now my next node address is 215. So it proves you that 100, 108, 215. This location values will proves that it is not storing in continuous memory locations. Okay. Now 108 will be updated here so that you can point to this location, and 215 is updated here so that you can point to this location. So in programmatical terminology we'll use this. Now look at this, look at this. So I'm not going to call this as my data, because if only 10 is available, I can call this as data. But only 10 is not there. Along with this 10, there is one more field which is address field. So this is data field and this is address field. As these two are not data, as these two are not address, these two are different. One is data, the other one is address. When we have different collections, then you have to take structure. What is structure? Collection of dissimilar data elements. So one data element is integer, the other data element is what? Address. Now why I have given struct node? Because it is going to point to whom it is pointing, to one more node, right? This 108 is pointing to one more node. That's what the data type of this pointer variable is, struct node. Okay, so this is what the syntax. Now look at the example. This is my example. So 10, 15, 20 are my values. I wanted to access, and the very most important point is linked list is a sequential access. It is not random access. You can't get the element in between as you can get the element in between into arrays. For example, arrayలో a of 0, a of 1, a of 2 ఉందనుకోండి. Then a of 2 element నాకు కావాలి అంటే, if I want to get a of 2, can I get? Yes, I can get. That's what the complexity of array is. What? Big O of 1, constant time. You can access any of the element, because all these are contiguous memory locations. And linked list is not such like. It is a sequential access. If you wanted to go to this 20, you have to come from the beginning. So that means it is a sequential access. To visit the last node, from first node we have to traverse. So this is what head. Get the difference. This is head node, that is first node. This is tail node, that is last node. And this is pointer variable which point this address. Okay. So this is all about the introduction of linked list. Now before I close it, I'll tell you some more things which are important as a summary. So I told you just the moment that it takes order of n, because it doesn't takes us to individual element access. The sequential memory access is given for linked list, but array is big O of 1. So linked list operations are this. What we can do with linked list, how we can implement linked list. So that is, you can create a node, you can insert a node in between, you can delete a node from any anywhere you can delete a node, and you can traverse from one to the last, and you can search. The very important is, as I told you, it is a sequential access. It is only possible to search linearly. So obviously binary search is not possible through linked list, and it is a dynamic size. It is what a clean summary of linked list. So the next video I'll talk about types of linked list. Thank you all.